Hello and welcome back. Let's finish up this last question where we were told that the cosine and sine of a couple of angles were. We were told where they are, both in quadrant 1, and then we were asked to find the sine of the sum of the angles and the tangent of the sum of the angles. So we have formulas for the sine of a sum of angles and the tangent of a sum of angles. So it just comes down to finding the right ingredients to plug in. So we did that last time. We found both the sine and cosine of both angles and plugged them into the sine, and we came up with this somewhat nice number. And now it's just going to be plugging them into the tangent and to the tangent formula. So first and foremost, let's find the tangent of an s degree angle from what we had before. So that's just going to be the sine of s divided by the cosine of s, which the sine of s was 3/5. The cosine of s is going to be 4/5. The fifths cancel, and this will be 3/4. The tangent of a t degree angle is going to be the sine of a t degree angle over the cosine of a t degree angle. The cosine we saw was 12/13. And the sine was 5/13 from up above. So the 13ths cancel and we get 5/12. So now it's just a matter of plugging it into our formula. Tangent of s plus tangent of t over 1 plus their product. Tangent of s plus t is going to be tangent of s, which is 3/4, plus the tangent of t, 5/12, all over 1 plus the product there. And then a lot of this just comes down to simplification. What I'm going to do very sneakily is multiply both the top and bottom by 12, just to cancel out some of these fractions. So 3/4 times 12, that will be 9. 5/12 times 12 is going to be 5. The bottom 1 plus, and then as I cancel this out, it'll cancel out with the 12 there. So this is going to be 3 times 5 divided by 4. And then here, the top will be, 14. The bottom, if I need to combine this with 4, this is going to be 4/4. So 4/4 plus 15/4 is 19/4. So this whole thing will be 4 times 14, which will be 56 divided by 19. So a lot of going on here. Most of it is just simplification using algebra. A little bit is finding the correct formula to use from trig. So the very last thing that we'll do is talk about some double angle identities. Doing some scratch work beforehand. So let's look at the cosine of an angle that is doubled. So first of all, if I want to take double an angle, that's just like adding the angle to itself. This is just the cosine of A plus A. Well, I know how to simplify a sum of angles inside of a cosine. So it's just going to be the cosine of the first angle times the cosine of the second angle, which just happens to be the same, minus the cosine flips sine, sine of the first angle times sine of the second angle. And right away, we can notice, oh, cosine of A times cosine of A, that's cosine squared. Sine of A times sine of A, that's sine squared. So this is pretty nice. We can write the cosine of 2A in terms of cosine and sine of A. But right away, okay, we've got some trig functions squared here. which means, oh, let's use our Pythagorean identities. Sine squared of an angle plus cosine squared of an angle is 1, right? So if I solve for the sine, for instance, this is going to be 1 minus cosine squared. So I can plug in sine squared into here. So this is going to be cosine squared A minus 1 minus cosine squared. And from here, I can simplify this. So I've got cosine squared A minus cosine squared A minus, that's a plus. This is going to be 2 cosine squared A minus 1. So we've got one formula up here, but we don't even need the sine. We can just write it in terms of the cosine. But I can also solve this in terms of the cosine. So this is going to be cosine squared is going to be equal to 1 minus sine squared. So we get a third formula. So instead of the cosine, I'm just going to write this. So instead of the cosine, I'm going to write 1 minus sine squared. Minus sine squared. So this is minus sine squared is minus 2 sine squared. So we, oh no, I started using thetas instead of a's. Oops. So we have 3 formulas for the cosine of a double angle. And I will review this in just a second as well. But we also have, again, some scratch work that I forgot to erase. So the sine of a double angle is a sine of A plus sine of A plus A. And I know that we've got a formula for the sine of the sum of angles. It's going to be sine of the first times cosine of the second plus sine of the first times cosine of the second angle. And that's just 2 times sine times cosine. And that's it. So this is pretty simple already. And then tangent of a sum of angles. So again, tangent of twice an angle is just going to be tangent of A plus A, which our formula is tangent of A plus tangent of the second angle, which also happens to be A, divided by 1 minus the tangent of the first angle times the tangent of the second angle. And tangent plus tangent is 2 tangent. And on the bottom, we've got 1 minus tangent squared. Cool. So we've got formulas for everything. I've written these down again. So if you know how to derive them, great. If you just want to write down the formulas, here they are. We have 3 cosine of double and angle identities. It's cosine squared minus sine squared, which we can turn cosine squareds and sine squareds into one another. So there's 3 ways to write that down. Sine of double of an angle, we just have the one formula, and tangent of double of an angle, we have right here. So 5 more identities. Again, you don't feel like you have to memorize these. If you do memorize them, great. They're really helpful. If not, write them down on a sheet of paper so that you can see all of the identities that you can use. And let's use a couple of these and see how this might work. So you just want to write the following as a single trig function. We've got 4 minus 8 sine squared 17 degrees. Okay, so this right now isn't just a single trig function. We've got, something over there, something over here. It looks like a big mess. But we've got something minus something sine squared. That reminds me of this guy. So we've got something minus something sine squared. Those guys look the same. So let's make it look even more the same. I can pull a 4 out. And now I've got 1 minus 2 sine squared of 17 degrees. Oh, and then this guy is just the cosine of twice a. So this is going to be 4 times the cosine of twice the angle in here. So what's twice 17? It's going to be 34. So this is 4 times the cosine of a 34-degree angle. So we can rewrite this seemingly complex thing just as, a single cosine with a coefficient up front. So there's not this isn't too bad. We just have to recognize, okay, so we have our double angle formulas. So as we use them, we're going to go from a 17-degree angle to a 34-degree angle. We just have to remember to double the angle on the inside. Let's do another one. So let's simplify the following. We've got 2 times sine of an angle, cosine of an angle. And again, sine times cosine, we should be thinking, 2 times sine of an angle, cosine of an angle. We have a formula for that, so we can simplify this right away. 2 times sine of a 97.5-degree angle, cosine of a 97.5-degree angle. Using our formula up here, this is going to be sine of 2 times the angle inside. Sine of 2 times the angle inside. So this is going to be the sine of, so 2 times 97.5 should be 195-degree angle. And we actually did this before. Maybe I can scroll up. We actually found the sine of 195-degree angle. This would have been in one of the previous videos. Yep, there we go. So we did all this work from before. There's our sine of a 195-degree angle, and there was our answer. So we can simplify that. It's a little bit of work, but we've already done that work, so we can just repeat that down here. So we already did that. So we'll just say check above.